There we go. But this is in the way, so let's move it over here. All right, let's figure it out. So remember that the derivative of the inverse is actually 1 over g prime of g inverse of x, which means that it's going to be the derivative of, and I'm looking now specifically for when it is 1, right? So we're doing it like at x equals 1. So I go find 1 for g because it's the inverse, and that means it's -3. Because again, we're switching x and y. How are you guys already lost? Which means g prime of -3 is, -1/2. Which is, look at those boys getting it right. Right? 1 divided by -1/2 would become -2.
Wait, no, he did it using only the graph.
All right, good for him.
How do you do that only using the graph?
Well, I mean, you do this, you just do it in your head. That's the only way.
No, you got it and stand in.
No, you literally, the only way to do it is to like do this and do it in your head. That's it. Anyways, let's look at it, shall we? All right, ladies and gents. So before, the relationship of a function being continuous at x and a function being differentiable at the same value. That's our whole goal, is to establish this. We're going to do some logic, meaning all differentiable functions are continuous, but not all continuous functions are differentiable. All right, think of it as like all girls are human, but not all humans are girls. Right? Same idea? Did that help, or you look more confused? Okay, anyway, it's a logic statement. I know you guys don't take logic at this school, which is very sad. It's super fun. Okay, so we've got this function, square root of x squared minus 4, and we're going to figure out at 2. And we want to know to begin with, well, first of all, sketch it. All right, so you're going to put it in your calculator. And you're going to be really good. That's like a little too steep there. And you're going to be able to tell me, hey, look, it's something like that. Amazing. Hopefully you can put that in your calculator and tell me. And if not, well, I did it for you. Try it later. Make sure you can. Now, based on the graph, if it's continuous at x equals 2, explain your reasoning. This means 3-part definition, right? So that means the first thing I need to do is figure out, does f of 2 exist? Well, if I look at the graph, yes, it does exist. It's 0. Then I need to look at the limit. Does the limit as x approaches 2 of f of x exist? Nope, does not exist. Therefore, f of 2 is not continuous. Right? Why do we say it doesn't exist? Well, because clearly from the right side it exists, but from the left there's no function to trace, so it can't possibly exist. Yeah? We've won. Victory. Yeah. All right, so now, once we've done that, we're going to check differentiability. Now, we can already kind of infer probably not, but let's actually do it to prove it. So I'll start with our original equation, which was what? Let's rewrite it as x squared minus 4 to the power of 1/2. And you're getting so good at these chain rules that you're going to go directly to here because you're awesome. Hang on, I'll explain. Why? Because we know that this is going to be like the 1/2 will come down. There's the 1/2. Okay? We also know that this is going to become -1/2. There's the -1/2 because we just threw it on the bottom with a positive exponent. And we have to multiply by the derivative of the inside, which is 2x. See? See? You're getting so good at these that you can do them all at once because you're amazing. Just take the compliment and run with it. All right, so then I want to figure out what is the derivative at 2. Well, I'm going to get 2 over the square root of 2 squared minus 4. Whoops. I can't have 2 over 0, right? Right, because I'm going to get 4 minus 4 here. So it's going to be 2 over 0. So therefore, this thing is also not differentiable. Differentiable means, like, can I take the derivative? So, not differentiable, I can't. Absolutely. We're just proving it, like, algebraically. Yes. Why? Because if I look at this thing, right, like, how can I do that? Well, it's easy to see that like here there's a tangent line, here there's a tangent line, here there's a tangent line. But if I try to do one here, there is literally an infinite number of tangent lines that I can put on a point. So anywhere that we have like a hard corner, or you'll often hear them called cusps, it's not differentiable. I can't do it.
If you want to prove that it's differentiable, it's just proving it's continuous.
No, because not all continuous graphs are not differentiable. We'll get there. Watch. Are you ready for it? This is one of them. All right, so then you're going to put this function in your graph in calculator. And you're so awesome that you figured it out. Or I helped you, whichever. I'm not really sure. But it looks like this. Okay? Because you did it in your calculator later. Or you paused the video and did it. For those of you at home. All right. So that's our sketch. Then is it continuous? So again, we can use our graph, but we got to do our 3-point definition. So does f of 0 exist? Yes, it's 2. Does the limit as x approaches 0 of f of x exist? Yes, it's 2. Therefore, it's continuous. And our reasoning, right, is that f of 0 equals the limit as x approaches 0 of f of x, which equals 2. This is the key. That's our like main point in that 3-point definition, right? Yes? Marita, are you okay there? Did you forget all your books?
Yes. She's like me.
They are online too, you know. All right, so that means that it's continuous. Now, based on our logic, that means that differentiability is possible, but we're going to see no, not so much. Because of that logic statement I made at the beginning. All right, so our original graph, let's write out the original again. It was x to the 1/3 plus 2, which means that the derivative, again, you're getting so awesome at these. No. It's not even a chain rule. It's just a power rule. It's that simple. Oh, no, it's not negative. Is that what you're going to say? It's negative if it's on top, but I'm making it positive by throwing it on the bottom. Okay. So then I want to know, all right, awesome. Hey, boys in the back, stop. Boys, you're too loud. Especially when I'm recording, right? Okay, f prime of 0. Well, I'm going to get 1 over 3 times 0. Whoops. Therefore,
It's
not differentiable. Can anybody see why it's not differentiable in this case? The tangent's going to be vertical like that. It has like a vertical tangent line, which means I can't do it because I would be dividing by 0 because the slope is 0. All right. Let's continue, shall we? Almost the same equation, except this time it's 2/3, which means that I'm still going to be here and I'm still going to look like this, but if I'm squaring that third, what does it look like on the left side? A bird. It looks like a bird, see? Remember those little kid birds you drew when you were little? No, you guys never drew those? Anyway. All right, the reason is because it is technically like the same graph, but then because we squared it, it's going to become positive or bigger, right? Okay. So can we figure out if it's continuous? Well, does f of 0 exist? Yes, it's 2. Does the limit as x approaches 0 exist of f of x? Yes, and it is 2. So because f of 0 equals the limit as x approaches 0 of f of x, and that equals 2, it is continuous. Now, obviously, guys, when you have a graph, you can look at it and be like, dude, it's continuous. But if we don't have it, this is how we can prove it, right? If we don't have the actual graph. Okay. What about differentiable? Well, it's going to be very similar.
It's a power rule.
Right, so let's start by writing out our f of x. It's just power rule, exactly. So it's x to the 2/3 plus 2, which means that the derivative, because you're so good at it, you're going to do it all at once and give it a positive exponent. So the 2/3 obviously comes out front. Then I subtract 1, and I would get x to the negative 1/3. But I'm going to put that x to the 1/3 on the bottom, so I don't have to deal with a negative exponent. Does that make sense? Okay, awesome. And then I needed to figure out, I'm running out of room, but we'll just do it down here anyway. F prime of 0, well, that gives me 2 over 3 times 0. Whoops, still can't do it. Wow, what happened there? Whooples. I don't know where the extra line came from. Anyways, so therefore, not differentiable. All right, so far, we're seeing what I had said earlier, right, in my logic statement.
Wait, because the tangent is going to be like this, right?
In this case, no. In this case, it's a case where the tangent line, again, is going to be like an infinite number of tangent lines, right? So that's why. So again, it's that hard corner or cusp. Okay, so based on what we've seen then, what does this mean? Well, it's the logic statement I said. Continuity does not imply differentiability. Hey guys, you're too loud. Especially if I'm recording.
We're talking about how bad is the red sweater.
Oh, yeah, it's terrible. Differentiability does imply continuity because continuity is a requirement, right? In the case of differentiability, we cannot be differentiable if it is not continuous. It's not possible, period. Can't do it. So therefore,
it's not continuous, it's not going to be.
Exactly. If it's not continuous, it is not differentiable. If it is differentiable, it must be continuous. Okay? Now, in order for it to be differentiable, then, that means that f of a, whatever point we're checking, must be continuous. Has to be. Okay? And very similarly to our continuity, the limit as x approaches a from the left of f of x must equal the limit as x approaches a from the right of f of x, right? So in other words, the limit needs to exist. But these are of the derivative, not of the original function, because then we would do nothing new. So in order to be differentiable, it has to be continuous, and the derivative limit must exist. Okay, because if not, it's like weird, right? It's like we've got that jump discontinuity or something. So, shall we apply this? I am waiting. We are waiting. Juanita's not. She's just not working. 9:35. What? Of course it will. All right, so let's actually try it with this function here. Is it continuous at x equals 3? Show your complete analysis. That means I need to do the three-part definition. G of 3 exists, and if we look, this is where it is equal to 3. So I'm going to plug in 3 to that equation and get that it's 2. Now, in order for the limit to exist, the right side and left side must be equal, right? So our left side has to equal the right side. We want to make sure that's true. And we already figured out the left side of it. And the left side was 2. So we really just got to work on that right side and go 5 minus 3. Well, that is definitely 2. So because 2 equals 2, and that equals what the function is, so in other words, g of 3 equals the limit as x approaches 3 of g of x, and it equals 2. So that is what allows us to say, therefore, continuous at x equals 3. Oh. And I guess that should probably be, that's more the answer. This is like our reasoning. Both of those should probably be circled. Amazing, right?
What do you do then?
What do we do? Nothing. That's all it asks us for.
No, but it's differentiable.
Now we got to see if it's differentiable. Exactly.
That?
So the two-part definition of differentiability was that it had to be continuous. Well, we just proved it's continuous, right? So we can say g of 3 is continuous. And we could say like C above, right? Because we just did it. We don't have to do it again. Now we need the limits of the derivatives to exist, okay? So we're going to take the derivative of the left side. So left side derivative equals question mark the right side derivative. okay, if that notation will make sense to you. So we're going to plug those in. So you're so amazing at these, but I'm going to write out f of x first. So f of x here, sorry, it was g, wasn't it? It's g of x. So g of x was the square root of x plus 1 on the left, and on the right, it was 5 minus x. So when we're doing it for the derivatives, that means, and you're amazing at these, so you're so good at them, it's going to be 1 over 2 square root of x plus 1. And this one is just going to be negative 1. Well, this is x plus 1 to the power of 1/2. So I pull down the 1/2, and then I multiply, or then I subtract 1. So x plus 1 to the 1/2 becomes x plus 1 to the negative 1/2. So I put it on the bottom. And then I multiply by the derivative of the inside, which is 1. That's it. So it's just a chain rule. It's just a chain rule. Right? And like I said, you're going to get really used to doing these chain rules with those to the power of 1/2. I did it in the previous questions. I worked it out step by step. Okay.
Can you just put 1/2 and then that?
That's exactly what I did.
It's just going to be exactly the same for every slide.
All right. So then I need to figure out what about at g of 3? Well, it's going to be 1 over 2 times 3 plus 1 square rooted equals negative 1, which is going to be 1/4, which sure as hell does not equal negative 1. Therefore, not differentiable. Because my derivatives, the limit of my derivatives do not equal each other. Make sense? I guess I should be more specific. Not differentiable at x equals 3. Because it could be differentiable somewhere else. And in fact, it is differentiable literally everywhere else, I think. No, it won't be differentiable everywhere else. Never mind. It'll be differentiable in a lot of places. But also, if this was negative, it wouldn't work. So, okay. Let's try it in a more complicated manner. Come on, you like systems of equations. Systems of equations. All right, how do we know that this thing is both continuous and differentiable? Well, actually, it says make it. K and M. You guys know we love K? Ouch. All right, well, let's first check continuity. So is it continuous? Well, we're going to force it to be continuous. So we already know that it exists at 3 because, well, quite frankly, there's an equal sign here. So all we need to do really is make the limit equal. So we need to make that left side and right side equal, right? So we have k, x plus 1, we're not even going to question mark it because we're forcing it this time, equals mx plus 2. But then we're going to do it specifically at x equals 3. So it becomes k square root of 3 plus 1 equals 3m, whoops, plus 2. Yeah, I'm just switching the order of them. And really, that simplifies as well. That'll be 2k. So 2k equals 3m plus 2. Awesome. What about differentiability? Let's use pink. Differentiability. It is continuous because we're forcing it to be continuous. We're saying as long as the relationship between m and k follow this, it will be continuous. But now we also need to make sure that it's going to be differentiable, which means that now we need to take the derivatives of those two things first, right? So first we're going to, let's use the fun word that my students made up, derivate. It's actually differentiate, but we're going to say derivate because it sounds funnier. And let's see, this one is going to be k over 2 times all of this stuff to the negative 1/2, which is really just mean that we're going to slam it on the bottom. Right? We all go to that? Yeah. And then I multiply by the derivative of the inside, which is 1. So we're good. And we're going to make that equal to the other side, which is just m. Just m. Right? And then we're going to do that derivative at x equals 3. So we'll get k over 2 times the square root of 3 plus 1, and it equals m. That's going to give us k over 4 equals m, or if you prefer, because I think it's a little bit easier, k equals 4m. And it's actually way easier because now I can take this, plug it into there, and solve for my variables, right? So I'm going to do a substitution, right? Because the two ways of solving systems of equations are what?
It's going to be 2 times 4m.
Yep.
Okay.
Because I can do substitution or elimination. We'll do elimination on the next one. This one we're going to do substitution because it's already solved for us. Like it's already done. K equals 4m. So then we put 2 times 4m equals 3m plus 2. Simplify that. 8m equals 3m plus 2. Which means that I'm going to subtract 3 from both sides and get 5m equals 2. Which means that m is equal to 2/5.
And then you do it.
Okay. Then I plug that into the other one. So to find k, I'm going to get 4 times 2/5, which is 8/5. And so our two variables are the way to make this thing continuous and differentiable everywhere is m is 2/5, k is 8/5.
Wait, why 4?
Why 4? Because the k is equal to 4m. So it's 4 times whatever m was. How do you feel about that? Any questions? We're good.
We should take a break.
Now the next one. What didn't you understand?
Let's take a stretch break.
The differentiable side? All I did is take the derivative of both sides,
Okay.
right? So the derivative of the left side was this. The derivative of mx plus 2 is just m. And then I put in x equals 3. And then that gave me my second equation. It's very similar to what I did for continuity, except that I had to differentiate them first. Now, if we look at the next one here, guys, we removed something. We didn't bother saying continuous. Why? Because why?
Because we made it continuous.
Kind of. We're going to make it continuous. If it's differentiable, doesn't it have to be continuous?
Yes.
So if I say make this thing differentiable at 1, that means I have to make it continuous at 1, or it won't work. Okay?
But you make it continuous first.
Yep, I will. So we'll start off with continuous, which just means that I'm going to make these two sides equal to each other. And I'm going to make them equal to each other. Well, you know what? Let's do it the long way. 3ax squared plus bx plus 1 is going to be equal to ax to the 4th minus 4bx squared minus 3x. But that's not really what I want. I want to do it when x equals 1, right? So then I'll plug in 1, which really just means all the x's go away, right? So it's just going to be 3a plus 2b plus 1 equals a minus 4b minus 3. Because all the x's are 1, and if we multiply by 1, nothing changed. Then I need to put it all on the same side. So I'm going to move it over. Well, I don't have to put all of it on the same side. I'm actually going to move it like both ways. So what I'm going to do is I'm going to move the a's and b's to the left and the numbers to the right, because it's usually a little bit easier if we set up our equations that way. You could put them all on the same side as well. It doesn't really matter. And so that'll be my first equation. Okay. Then let's do differentiability. God, that is a really long word to write every time. Differentiability. I'm going to start starting diff, I think. That's too much. Just diff. Okay. So again, I'll start by writing out the f of x's for you. Equals ax to the 4th minus 4bx squared minus 3x. But then I need to derivate them or differentiate them. I just like derivate. I think it's funny. I had a class like 3 years ago that accidentally called it derivating, and then I just loved it. I thought it was hilarious. So did they. So we just always called it derivate. So this will be 6ax. Huh? Where? Ah, yes, thank you. There should be a 2 here. So 6ax plus 2b, and then the 1 goes away. Over here, I'm going to get 4ax cubed minus 8bx minus 3. Because remember, I'm pulling down the exponent and subtracting 1 from the exponent. Okay? But I don't really want just the derivative. I want it specifically at x equals 1. So again, all of my x's really just go away if I'm plugging in a 1. So 6a plus 2b is equal to 4a minus 8b minus 3. And again, let's throw all the a's and b's to the left because I think it'll be easier. Minus 4a plus 8b. So we're going to get what? 2a plus 10b equals negative 3. And so now this is going to be easier if you look at it to do a elimination. Because if I have those two, it's easier for me to line them up and subtract because the a's are going to cancel, right? They're going to be 0. And then I'm going to get, let's see, 6 minus 10b will be negative 4b. Negative 4 minus negative 3 is going to be plus, nope, minus 1, sorry.
So we have to compare the continuous and that the differentiability thing.
I have to do what? I have to compare them? Well, yeah, because that's a system of equations. I'm just using continuity and differentiability to get my two equations, and then I need to actually solve for what a and b are. So in this case, b is 1/4, and then I need to find a. So let's see, we'll use that blue one. It was easier. 2 times a plus 6 times 1/4 equals negative 4, which means 2a equals 3/2. Sorry, not equals. Should have been plus 3/2. Equals negative 4. And probably I'm going to divide by 2 now because I think that's easier. And so I'll get that a plus 3/4 equals negative 2. And then I need to subtract that 3/4 from both sides. And guys, you don't need to show every single step like this. Like this is a little bit painstaking. So feel free to like take some shortcuts. This would be what? 8, 9, 10, 11, negative 11/4. And so my answers are going to be 1/4 and negative 11/4, or negative 11/4 and 1/4. Probably put a first. And that's it. That will make it continuous and differentiable, or differentiable. There we go. Awesome. That is it.